Suppose you wish to perform a linear regression on a dataset. The calculator can do this, and here's how. First, we shall consider a set of data that's given here. We shall enter the x-coordinate in L1 and the y-coordinates in L2. Then we shall perform a linear regression and interpret the results. Now this video assumes the diagnostics are turned on. So we'll hit Stat, and we'll hit Enter, and then we'll begin entering in the first number in each one of these ordered pairs in L1. Those are the x-coordinates. And then we'll scroll over to L2 and we'll begin entering the second number in each one of these ordered pairs, as those are the y coordinates. Okay, now that we have our lists entered, we may conduct the linear regression. So we'll hit Stat, we'll scroll over to Calc, and then we'll scroll down to option 4, which is this LinReg ax+b. We'll select that one and we'll hit Enter again. Now the calculator outputs the slope as the a value and the y-intercept as the b value. The r squared that's listed here, this r squared value, this is the coefficient of determination. And for linear regression, it actually is the square of this r value listed right below it. The value of r is called the correlation coefficient. The coefficient of determination gives an indication of how much of the variance is explained by the model. And the closer this value is to 1, the better the choice of model. The value of r, this correlation coefficient, is a measure of how linear the data is. This value can be any value between -1 and 1. And the closer the r value is to -1 or +1, the more linear the data is. Now suppose we wish to see a graph of this situation, and we can do that on the calculator, and here's how it can be done. We'll go ahead and hit second, and then y equals. That'll take us to the Stat Plots menu. We'll turn the first plot on. We'll go ahead and select the scatter plot option. We'll let the x list be L1, that's where the x coordinates were placed, and we'll let the y list be L2, that's where the y coordinates were placed. And we'll choose the mark as the box because those are pretty easy to see when it comes to the graph. Now I'll go ahead and hit Zoom, and I'll scroll until I get to Zoom Stat, this command right here. And then I'll hit Enter to bring up the graph. Now at this point we have a scatter plot. If we want to have the linear regression line plotted along with the scatter plot, we can do this on the calculator, and here's how. We'll go back under Stat, we'll go back under Calc, and we'll go ahead and select this LinReg command again. But here we're going to do something different. We're going to go ahead and call up the list. L1 is the x coordinates, and then a comma, and then we'll call up L2 because that's where the y coordinates are, and then a comma, and then we're going to hit this vars button, scroll over to yvars, and select function. I'm going to select y1 so that I can put the output into the y1 slot. Now we have the same information that we saw before, but if we hit the y equals button, this button right here, if we hit that one, we'll see that we now have our line copied over into this slot. And we can graph this regression line now with the scatter plot, and we can get an idea about how good our line actually fits this data. Now this method demonstrated here is the one that most people would use, especially if they're not a statistician. But if you are studying to be a statistician, then you'll want to use a slightly different command. So we'll go back under Stat, we'll go over to Calc, and this time we're going to scroll past this one, this option number 4. We're going to keep scrolling down until we get to this command. Now this linear regression command is the one that statisticians would most likely use, because when statisticians report results, they write the variables in increasing powers. So we're going to execute this command, and we're going to see what the differences are from the previous results. So we'll go ahead and hit enter. We'll go ahead and call up list 1 for the x coordinates, then a comma, and then we'll call up list 2 for the y coordinates, and then another comma. And then again we'll hit vars, and then scroll over to yvars, select function, and this time we're going to select y2 to store the results in. We'll go ahead and execute this command, and here you can see that now the a value is the y-intercept and the b value is the slope. The r squared and the r values are not changed, so let's compare these results when we hit the y equals button, and we can see that the only difference is in the placement of the terms as far as the calculator is concerned. Since addition is commutative, you can switch the order in which you add numbers. It doesn't make a difference in the results. We can go ahead and see that that's exactly what's happened here. And if we graph these results, we're going to get exactly the same line. So if you are not studying to be a statistician, you would likely choose option 4 under stat in calc. You would most likely choose this option, where if you are studying to be a statistician, you would be encouraged to select this option, option number 8 on these calculators. And this is how you can perform a linear regression with a data set on the TI-83 or TI-84 calculators.